In this video, we're going to do a quick introduction to polar coordinates. Take a moment to admire the cute comic. So the first thing we're going to do is just some plotting. So to plot 2 pi over 3, that means that our radius 2 and our theta is pi over 3. So we're going around a circle to plot these things. So we know a full circle around is 2 pi, so pi over 3 would just leave us right here, and we draw a radius of 2. And so that's how I find that coordinate there. Let me just do a couple of these, and I think you're going to get the point. The next one, if we wanted to plot, here's a radius of 1, and our theta is negative 3 pi over 4. So since the angle is negative, we're going to be going the opposite way around. Here would be pi over 4, 2 pi over 4, 3 pi over 4 is right here, and our radius is just 1. So you'll see that this radius is like half the length of this radius here. Now that you kind of understand how to plot the points, let's look at the other part of this question. It says, then find 2 other pairs of polar coordinates, one with a radius greater than 0 and one with a radius less than 0. Let's start with radius is greater than 0. So if I want another point, then we know to hit this point again, we would just go another 2 pi around the circle, right? So the radius is still going to be 2. And then our theta is just add another 2 pi and we'll end up in the same space, right? 2 pi is a full time around. So another coordinate that's going to land us here would be 2, 7 pi over 3. And that one's easy. Now, when it says radius is less than 0, then we want to look, instead of the radius being 2, let's look at the opposite of 2. So pretty much that would be, instead of going this way to go to 2, that would be going this way to go to negative 2. Okay, that would be a radius of negative 2, pi over 3. So this point right here, right now, would be negative 2, pi over 3. But of course, my goal is actually to hit this point again right here, but with the negative 2. So that means if I started here and then I reflected at negative, then I would land on this point. So what is this point right here? Well, this was pi over 3. So pi over 3 over here is going to land us at, this right here is 1 pi, which is 3 pi over 3. So this point right here would be 4 pi over 3. In other words, negative 2, 4 pi over 3 would land us also at this point right here, which is our goal. Let's try another one. Radius is greater than 0, and this one is just saying, what's another way to define this point? Well, another way to define this point would be just thinking about it being from here. That would be a positive. So 1, 5 pi over 4, right? Because negative 3 pi over 4 is the same thing as 5 pi over 4. They're equivalent. Another way to think about this would be the same way that I kind of outlined it here. So negative 3 pi over 4 plus 2 pi is going to wind us up at 5 pi over 4, because I have negative 3 pi over 4 plus 8 pi over 4, which is 5 pi over 4. Now, if my radius is less than 0, then that would be a negative 1 radius. Well, what is that? So that would be, take this point right here, and then if I had negative 1, that would plot me up over here. Again, this was going pi over 4, so that means that this much should also be a pi over 4. So if I was at negative 1, pi over 4, then that would start me at pi over 4, and then negative 1, instead of being here, would reflect us down here, and that would be my equivalent point. Now we're looking at negative 1 pi over 2. So that means let's start at pi over 2, right? 1 pi over 2, and then since it's negative 1, that reflects it down here. So that's how I plot the point negative 1 pi over 2. Again, I start with a radius of 1 at pi over 2, and then I reflect it down. Now r is greater than 0 is going to be the one that I have to think a little bit more about, because the r is less than 0 is what I already had, the negative 1. And so I would just do pi over 2 and then add another 2 pi, which would leave me at negative 5 pi over 2. So what would be another way to think about this point right here? Well, if the radius is 1, then I'm going over 3 pi over 2. So that's it. If my radius is 1, then I would be going over 3 pi over 2 as my theta. Now in these problems here, they're asking you to plot the point, which they're already plotted. Again, if I want to plot 1 pi, then that's just a radius of 1 and a theta of pi. In this one, they ask us to plot 2, comma, negative 2 pi over 3. So we would just go over negative 2 pi over 3, like that would be our radian measure, and then the radius of 2. So that's twice as long as this one, for instance. And then they ask us to find the Cartesian coordinates of that point. So we know that our x is equal to r cosine theta, and our y is equal to r sine theta. And so we're going to use that to find the Cartesian coordinates. So in this case, x equals r cosine theta is going to be 1, that's our r, and our theta is pi, cosine pi. And so the cosine of pi is negative 1. So 1 times negative 1 is negative 1. And the y coordinate is going to be r sine theta, which is 1 sine theta. And the sine of theta is 0. So that's going to be 0. So our Cartesian coordinate is just x comma y, negative 1 comma 0. In this one here, we have x equals r cosine theta, which is r in this case is 2, and then we have the cosine of negative 2 pi over 3. So what is the cosine of negative 2 pi over 3? Well, let's just make a little triangle here. So if this is negative 2 pi over 3, I have pi over 3 left, which is 60 degrees. Opposite the 60 degrees is root 3 over 2. But since we're going down, that's negative. And then this would be negative 1/2. It's just a 30, 60, 90 triangle. That's how I know those side lengths. And so the cosine is going to be the adjacent, which is the negative 1/2. So I have 2 times negative 1/2, which is negative 1. And then y is r sine theta, which is 2 sine negative 2 pi over 3, which is 2 times, and then the y was the negative 3/2. The opposite is the negative 3/2, which is negative root 3. And so my coordinate is going to be negative 1, negative root 3. And that's my Cartesian coordinate. So again, just make sure that you're drawing the triangle in the proper quadrant, and make sure that you're labeling the signs, the positives and negatives, because that's where people often mess up. In this one, they're asking you to graph negative 2, 3 pi over 4. So basically, I start at 2, 3 pi over 4, that would be right here, and then I reflect it down here to get the negative. So this is my coordinate in this case. To get the x, I'm going to do x equals r cosine theta, which is negative 2 cosine of 3 pi over 4. And what is the cosine of 3 pi over 4? Well, the 3 pi over 4 lives over here. So don't get confused, even though this is the point that we're plotting, we are asking for r cosine theta, and our theta is the 3 pi over 4. So I'm over here to make my little triangle to figure out what the cosine of 3 pi over 4 is. So if this is 3 pi over 4, that means pi over 4 is remaining. That's a 45, 45, 90 triangle. So that means this is root 2 over 2, and this is root 2 over 2. This is a negative measure. This is a positive measure. So the cosine of 3 over 4 is going to be negative root 2 over 2. In other words, I get root 2 when I multiply that out. Now y is going to be r sine theta, which is negative 2 sine 3 pi over 4, which is negative 2 times positive root 2 over 2, which is negative root 2. So my Cartesian coordinate would be root 2, negative root 2 as my answer, which is a positive x and a negative y, which would land us in the fourth quadrant, which is where our point is. So that's a little check to make sure you're correct. The next question says, given the Cartesian coordinate 2, negative 2, you want to find the polar coordinate. So now we're going the other way around. So in part 1, let the r be greater than 0. So we know that x squared plus y squared equals r squared. And so I'm going to use that to figure out what my r is first. I know my x is 2, so 2 squared plus negative 2 squared equals r squared for plus 4 equals r squared. So the r is root 8, which is 2 root 2. Then I know that my x is r cosine theta. I know my x is 2. Now I know my r is 2 root 2. So I can solve for theta. Divide both sides by 2 root 2, and I get 1 over root 2 equals cosine theta. If that doesn't immediately come to you, then you know that 1 over root 2 is the same thing as root 2 over 2. So that should help you get back to your 45, 45, 90 triangle. And you should know that the theta is pi over 4. But we have to think about where is cosine positive on the whole spectrum from 0 to 2 pi. Cosine is positive whenever the x is positive. So that's in this quadrant here, in quadrant 1, and also in quadrant 4, the cosine would be positive. And that would leave us at pi over 4, and also down here, which is 7 pi over 4, right? Because this is 2 pi, which is 8 pi over 4. Fall pi over 4 short, that leaves us at 7 pi over 4. So theta could be either of those. Now, how do I choose? Well, I know that 2, negative 2 is down here in the 4th quadrant. So that means that I should choose the 7 pi over 4 as my coordinate, and I should throw the pi over 4 out because this lives in the 4th quadrant. So my theta is actually going to be the 7 pi over 4. In part 1, where my r is greater than 0, I just use this radius, which was greater than 0, 2 root 2, and my theta is 7 pi over 4. In part 2, for r is less than 0, then I would be using the radius of negative 2 root 2, and I have to think of reflecting this thing up here, right? Because this point reflected negative would land me over here as my actual point. We know this reference angle is pi over 4, so this whole thing would be 3 pi over 4. In other words, negative 2 root 2, comma 3 pi over 4 would also land me over here. And so that's my answer to that question. Final question is just to sketch the region in the plane consisting of the points whose polar coordinates satisfy these conditions. So if the radius is between 1 and 2, literally all I do is draw a circle with radius 1 and a circle with radius 2. So radius 1 would be this circle, and radius 2 would be this circle. Oy. Sorry, this looks like an oval and not a circle. Just use your imagination a bit. And then if it's between 1 and 2, that would be this shaded region would be my answer. That's it for that. The next one, let's start with the radius between 2 and 3. So you'll see this one's non-inclusive, so I'm going to have dotted lines, whereas this one was included, so it's solid. So let's start with just those circles. And I'm going to just draw dotted ones because, again, it's strictly less than, not less than or equal to. Okay, that's good enough. And then where is 5 pi over 3? Well, this is 2 pi. 2 pi is 6 pi over 3. So fall pi over 3 short, and that's going to leave us at 5 pi over 3. And then 7 pi over 3 would be 6 pi over 3 and go pi over 3 over. So that's going to be around here. And so the region between 2 and 3 would be all here. And then I just want to go between the 5 pi over 3 and the 7 pi over 3. And that's it. That's my answer to that question. And that's it for this lesson.